Hi all, welcome to Geeks for Geeks. My name is Nitin Kaplas. Let's talk about today's problem. Our problem name is count pairs in an array. Let's read the question first. Here we are given an array of n integers. We have to count all pairs in such a way that I into array I should greater than j into array j. Here we are given the condition of ij, right? So in the first example, if you see n equals to 4 and we are given an array 8, 4, 2, 1, right? Here the output is 2. And in the second example, we have given the n equals to 7 and array is 5, 0, 10, 2, 4, 1, 6. Here the output is 5, right? So let's understand this problem better. So in the question we are given, we have to count all the pairs where I into array I greater than j into array j, right? So this is the condition of it. And also I is greater than equal to 0 and j is also the same thing. J is greater than I and less than n, right? This is the condition of it. Okay, so how we can solve this question? So the first intuition which came to my mind is simply we use two loops, right? Solution 1 here is we are using two loops, two for loops, right? And currently I am at here, for example my I is here, right? And my j is here. J is pointing to I plus 1. Let me write here I equal to 0 here. So in this case my I is 0 into this condition. 8 is greater than j is 1 into 4. No, it's not. So here my count initially is 0. It remains 0 when I am at I equal to 0 and j equal to 1. When my j increment, let me write here, j is now at index 2. Here if I am a check, 0 into 8 is greater than 2 into 2. No. When j equal to 3, so 0 into 8, 3 into 1. No. So it means when I equal to 0, I don't get any pair, right? So let's increment my I here. Now my I is pointing to 1. Okay. So now my I is pointing to this, right? And j is starting with 1. Let's check here. So my I is 1 into 4 is greater than, here I am pointing to index 2, 2 into 2. No, right? So when I am j equal to 2, here, sorry, it's for 2, right? It's for 2. When I am j equal to 3 here, so if you see 1 into 4 is greater than 3 into 1. Yes. So first I get my pair, right? So now after that, when I am going one step ahead, I equal to 2, j is 3, right? If I am seeing here, so my I is this, j is this. So if you see here, 2 into 2 is greater than 3 into 1. Yes. So again I increment my count which is equal to 2. So here when my I equal to 3, if I increment it, j equal to 4, right? So it's out of bound. I don't get any pair, right? So here my output is 2. So I return this as my output, right? So if you need the pseudocode, so simple pseudocode is when I equals to 0, I max go to this element, right? And here in this second loop, j is always I plus 1, j less than n, right? And j plus plus. Now here I have to check if I into array I is greater than j into array j, if it's count plus plus, right? And at the end of it, we just return my count, right? Here my count is 0 initially, right? So this is a simple solution to solve this question, right? But my time complexity to solve this question is n square. But if you see the constraint, we have to solve this question n log n, and we can use the space n log n as well, right? How we can solve this? So let me write here the array again, which is 8421, right? 8421. Now this is the condition: I into array I should greater than j into array j, right? If I modify my array, the first step to solve this question is just modify my array, right? So let's modify my array. I modify my array as I into array I, right? If I do the multiplication with the index as well, right? Let's suppose 0 into 8, which is 0, 1 into 4, which is 4. Here I do the same steps, 2 into 2, 3 into 3. Now I have this array, modified array, right? Where I'm do this computation, I into array I, or say as j into array j. So now this question is similar to solve count inversion problem, right? It's very simple problem now. When we convert this into this case, right? When I convert this array, normal array, into this condition, now we can easily solve using this count inversion. I strongly recommend, if you don't know how to solve count inversion problem, please first solve that question, right? And solving that question, there is also a prerequisite to solve count inversion, which is merge sort, right? If any one of you don't know about the merge sort, please first understand this merging sort part, how we can solve this, and after that you solve count inversion. So it's very easy question when you solve these two steps, right? These two questions. Now let's move to the how we can solve this. Now our modify array is 0443, right? Let me write here 0443. Okay. So how we can do the merge sort part? So if you see here, it's a basic algorithm, right? Standard algorithm where my low is pointing to the first element, right? And high is pointing to the last element, right? Now, in this case, we have to find the mid. So what's my mid is? Mid is 0 plus 3 by 2, which is 1. So this is my mid, right? So basically, merge sort is divide and conquer, right? So let me divide it. So I divide into the left half where it is this low to mid. So here I am writing 0, 4, right? I divide this array into two halves. Now in the right side, I have mid plus 1 to high, which means 4 and 3 is in this side, right? Now again, we are going to the again divide part. This is my low, this is my high. 0 plus 1 by 2 is 0. This is my mid. Again I go to the divide this array, right? Now again, if I go into the right side of it, it's giving me this 4. Now in this case, my low is pointing to the same index, right? High is also pointing to the same. So this is a stopping condition, right? Stopping condition, we go back, right? And here in the right side, again low is pointing to this, high is pointing to this. It's also a stopping condition, right? Okay, now in that case, we make a temporary array here, right? Let's make a temporary array which is of size high minus low plus 1, which is of the same size of it, which help us to sort the sub array, right? That sub array, right? It helps us to store that into the sorting part. So here what I'm doing is, so here if you see, my low is pointing to 0 index, right? And high is pointing to this. My mid is pointing to this. So I just divide that array into two halves. First is this, second is this, right? Okay, so what I'm doing is, now my I is pointing to low. Let me write here, this is my low, right? As you see, this is my low, and my j is pointing to this, which is mid plus 1. Here my mid is this, I am pointing to mid plus 1. This is my j. So I have to check this part, 0 part. If 0 is, its array of I is, which is 0, it is in the sorting part. It means that the condition which we want here, array I should greater than array j. Array j. If it satisfies, we have to count it, right? So if you see here, it's not satisfy this condition. So simply what I'm doing is, I just take the smallest element and put into the temporary array, right? So I'm putting that into there. Okay. After that, I just increment my I. So it is out of bound, right? The same step which we are doing in the merge part. It is out of bound. So after that, what's the element in both the array left? I just simply add into the temp. So it is filled. So it's not. So I am just filled that element into temporary array, right? So temporary array simply tell us that I am in the sorting. I sort that array, right? So this is my temporary array, right? For this case. Now, here my count initially is 0. Here remain at 0 in this case. Now its left part is over. Let's solve the right part. In this case again, my low is pointing to this, right? My high is pointing to this. My mid is this, right? So I divide that array into two halves. So this is 4, right? This is my 3, right? Again, low is pointing to this, high is pointing to this. Again, low is pointing to this, high is pointing to this, right? This is a stopping case. Again, I divide this array. Let me change the color, right? I divide this array. So I divide this array. Low is pointing to here. So let me erase this. I have two sub arrays here, right? I'm solving for this case, right? It divided into two halves. So I is pointing to this case and j is pointing to this case, right? So in this case, if you see this condition satisfied, array of I is greater than array of j. Yes, yes. So just increment the count. I am increment my count and I just increment the j plus plus here. So if I go for the j plus plus and j plus plus, here also I make a temporary array. Let me make a temporary array which is of the same size, this size. It means 2 size, or we can say that high minus low plus 1 size, right? 2. So first element here is 3. I put the element into the temporary array and increment my j here. So now j is out of bound. What's the remaining element left? 4. So let me add into the temporary array. Now, if you see here, I have these two. Let me also write in the this color. After I have temporary now, I have to change that into the original array, right? So I am just shifting to this array. This is my original array, right? So I have temporary array here also. I have to change this original array. Let me change this. So now it's look like 3, 4, right? It's 3, it's 4. Now this remains 0 and 4, right? Okay. So now again to solve this part, we are again divide this into the two halves. So we have these two halves, right? So let me erase this so that we can do the dry run for this case also. Now my I is pointing to the first element of this half and j is pointing to this half, right? Okay, let me erase this down part. I hope you understand this. Now if you see, this is I, right? This is j. It's follow this property, this condition. No, I 0 is not greater than 3, right? So we simply, what's the smallest here? 0 is the smallest. So I make here also temporary array which is of the same size as, right? Okay, so here this is smallest, just put that into it. So my I is pointing to this now. Okay, so here you have to check 4 is greater. Yes, 4 is greater. So what you are doing here is just do, if 4 is greater than 3, it means all the elements which is here, right? For example, here also having element, right? All the elements are greater. So simply we are doing the count here. Count plus equals to mid plus 1 is the size of it. This array having the size of mid plus 1. Why? Because mid is pointing to this, mid plus 1. Mid is pointing to 1, right? And mid plus 1 means this left half have 2 size. It's of the 2 size. So mid plus 1 is a size minus where we are standing right now. We are standing at 1. So this is a simple step, which is I, right? Mid plus 1 minus I is the total number of elements which satisfy my property when my j is at 3, right? So simply what's my mid is? Mid plus 1 is 2. So I am pointing to 1 index minus 1, which is 1. So let me increase this by 1, right? Now, after that, what I am doing is, it's follow the property. So in this case, I have to put 3 here and increment my j. Now my j is pointing to 4 now. Again, we have to check. 4 is greater than 4? No. So just add 4. For example, I am adding 4 this and increment my I. It's out of bound. What's the remaining element? 4 is the remaining. Just put that into it, right? So after that, this is my temporary array. I have to shift all the elements into the this part, right? Let's add into it, which is 0, 3, 4, 4. Now if you see my original array, right, it's over, right? All the subparts, it's over. What's my count here? My count is 2. So that is my answer. I have to return here 2, right? So it's a very simple if you know the merge sort and also know the how we can do the count inversion part, right? So same steps we are doing here. Let's code this now. So the first step is to change my array, right? We have to modify my array. So let's modify it. What I'm doing here is array I is equal to I into array I. This is simple step, right? Now my question is convert into the count inversion question. Let's write the function count inversion now, right? Inside this I am passing array and size of it, right? After that, what I'm doing is let's create a count inversion array. Okay, inside this I make a 2 pointer. As you know, the merge sort we have to use the 2 pointer here. So let's make a 2 pointer which is low and high is pointed to n minus 1. Okay, after that we call merge sort, right? Let's call the merge sort. Here we have low, here we have high. Okay, now let's create the merge sort. Inside this again I'm doing the same steps, right? I create the 2 pointers. Inside this, if you know that, what's the stopping condition of merge sort? When we are dividing that array, right? When this is the simple step. When high is greater than low, we have to do the dividing part, right? But it's not, we have to return that, right? So in that case, we are calling again merge sort, right? Before calling, we have to find the mid. Let's find the mid first. Mid is low plus high by 2, right? Now in the merge part, we have to pass array low up to mid, right? Because we have to divide into 2 halves, mid plus 1 and high, right? After that, we have to merge, right? We have to call the merge function, mid and high there, right? Now let's write here count initially is 0, and what's the count we have in the left half? We have to add that. Similarly for the right half and for the merge function, at the end of it we have to return the count, right? So now let's, our last function we have to create, which is merge. So let's create the merge, where we have first argument as array, second is low pointer, mid and high, right? Okay, what we are doing here is, first we are creating a temporary array, right? Where we are storing that element into the sorted part. So what's the size of it? As I said, what's the size of your original array, right? Original subarray. So let me create temp, which is of size high minus low plus 1, right? Okay. Now, what I'm doing here is I create a pointer which is I, right? Which is pointing to low, and your j is pointing to mid plus 1, right? As you see in the try run part, when I complete my dividing part, now it's time to merging, right? So if you see here, my I is pointing to this, right? My j is pointing to this, right? So this is what? This is low. What is this? 3. 3 is, if you see in this case, right, it's the modified part. Initially it's 4, 3. So 4 here is mid plus 1. That's why we are using here mid plus 1, right? Now, my k is 0, right? This is the condition. When I is less than or equal to mid and j is less than equal to high, right? Till then we have to traverse that both the arrays. We have to compare that both the arrays. If ARR of I is less than or equal to ARR of j, right? In that case, it means it's not satisfy the condition. So what I am doing here, simply add that element into it, smallest element into the temporary array. So here smallest is this. Else what I am doing is count plus equals to mid plus 1, as I earlier tell you why we are using here mid plus 1 minus I, and adding that smallest element into the temporary array, which is array of smallest here is j plus plus, right? Now what's the remaining we are left? We have to add that temp of k plus plus is equal to array of I plus plus. Okay, same for the right side part. Temp k plus plus is equal to array of j plus plus, right? Now at the end, what we are doing is we are just update my original array using temporary array. So here my I is pointing to low and j is pointing to 0, right? And j is running till its size of temporary array, which is high minus low plus 1, and here we are adding I plus plus, and here array I plus plus, sorry, array I is equal to temp of j plus plus. Simple. Okay, at the end we are just return my count part. Okay, so let me here initialize my count, right? Okay, so this is the simple code of it. Let's compile and check it's working fine or not. Yeah, it's working fine. Let's submit and check. Yeah, as you see, all the test cases are passed, right? Now let's talk about the time complexity. If you are done that question, so you understand the same complexity here is. Time complexity of this question is big of n log n, right? Because we are just doing the count inversion question, right? Just modify my original array, just implement that idea, right? So its complexity is n log n, right? Hope you understand this question and solution. Thank you so much.